Hello and welcome to Math 200 Online Statistics at Cañada College. My name is Lapuz. In this video, we will take a look at a homework problem from section 8.5. It says that workers at a certain soda drink factory collected data on the volumes in ounces of a simple random sample of 24 cans of the soda drink. Those volumes have a mean of 12.19 ounces and a standard deviation of 0.11 ounces. And they appear to be from a normally distributed population. If the workers want a filling process to work so that almost all cans have volumes between 12.04 ounces and 12.60 ounces, the range rule of thumb can be used to estimate the standard deviation, and that should be less than 0.14 ounces. They want us to use the data to test the claim that the population of volumes has a standard deviation that is less than 0.14 ounces, and they want a 0.01 significance level. Alright, so our claim is to say that the standard deviation is less than 0.14. So there is a less than sign for C and there's a less than sign for D. Now the h0 should have the condition of equality. I think either of these should actually work, but we've been used to having the h0 to be an equal sign. So let's select C. Alright, they want us to compute the test statistic, and let's see what else they need. For that, we're going to go to our Google Sheets, and let's remember that the standard deviation is 0.11. So our standard deviation is 0.11 ounces. We have 24 cans that we checked. Notice that we don't really need the mean because our formula here is only asking for n, s, and sigma. And sigma, as in our null hypothesis, is 0.14, 0.14. And then they want us to use a 0.01 significance, 0.01. Now the tail for this, if we remember, it's less than. So when we have a less than, we're going to use the left tail. Okay, I think we should be set to find our test statistic formula. Our test statistic is going to be a chi-square test statistic, and this is going to equal to, according to this formula, n minus 1. So it's 24 minus 1, close parentheses. We want to multiply that by s, and we want to square that, so that's s squared. And then we're going to divide by sigma, and we're going to square that as well, divide by sigma squared. Our test statistic is 14.19897. So let's see what this has to say. We want to round out to 3 decimal places. So this is the 4th decimal place is 9, and so we need to add 1 to the 8. Next, they want us to find the p-value. So this is a left tail test, and we want to find the distribution area to the right of that, because the tail is happening on the left side. Well, our p-value is going to be the tail on the left, so actually we just want to find the left side of this. Sorry. So the area to the left of this critical value, I'm going to type in equals, and then chi, that's C, that's CHI, SQ, chi-square, and when we're finding the area, we want the probability, it's finding the area, and we're finding the distribution. So the distribution on the left tail, if we wanted the distribution on the right, we would choose this RT, but this one we want a distribution on the left because the tail is happening on the left side. So I'll select this one, and what are they going to ask? They're going to ask for this value, comma, and then they're going to ask for the degrees of freedom, which is going to be n-1. So it's going to be n-1. And you can always double check to see what it's asking for. Oh yes, it's also asking for whether it's cumulative or not. So let's go ahead and say true for cumulative. And then we're going to have our p-value of 0.0789. Let's put that in. They want us to round to 4 decimal places. So 0.0789. 6 is bigger than 5, so we'll add 1 to the 9, and that would actually make this a 90 instead of an 89. So that's rounded off to 4 decimal places. Now our p-value compared to our significance level, our p-value looks like it's bigger than our significance level. So whenever our p-value is large enough, then we fail to reject the null hypothesis. So we do not reject the null hypothesis because the p-value is bigger than the significance level. And when we don't reject the null hypothesis, we cannot support the claim if the claim is the alternative hypothesis, and we cannot reject the claim if the claim was a null hypothesis. So remember that our claim was that the population standard deviation is less than. So our claim was the alternative hypothesis. So in this case we were trying to support it, but we failed to reject the opposite of that, the null hypothesis, so we cannot support the population standard deviation is less than 0.14 ounces. So there's insufficient evidence to conclude or support the claim to conclude that the population standard deviation is less. So let's check it. Alright, I hope that helps.